So today we're going to see one more algorithm in a machine learning whose name is support vector machine or SVM. Okay, it is one of the most popular algorithm and it is used for both case studies which where you have to do classification as well as the regression. Classification means where you have a categorical output and regression means where you have to classify continuous variable, right? So what do you mean by this SVM and why do we use this? So just by looking into this image, what kind of like idea are you getting? What I just wanted to know your imaginations, or like just by looking into the image, what are you thinking? Can anyone try? What?
Looks like uh, it is picking the nearest distance like KNN.
Okay. What is this blue and green?
It's different classes and
No.
they are calculating the distance.
Distance they are doing, but what actually this blue and green? I told
It's
many
like
many times.
two data group. I think two
Yes,
different.
yeah, these are the data points.
Okay.
These are the data points. When you combine this, then it will belong to the different categories or classes that you said, Urmila. So here, these are the data points. Each specific dot that is either blue and green are the data points. Data point means that you wanted to classify. For example, if you are categorizing the candidate, whether he is from Texas, Irvine, or he's from New York City or California. So, what are the things yet you have to consider? Like his current location or his address or multiple things. So, that are particular data points. So, support vector machine is another one classification technique. The goal of SVM is what? To find out the best decision boundary. What do you mean by decision boundary? You can see this line, right? It's actually a classification line that are classifying into two categories. Okay, so these are called as a maximum margin, and this dash two lines are what they are called as a hyperplane. Means what does it mean? That we have to create this two dash line in such a way so that whenever any new data point will come, they will classify correctly. Okay, for example, let me explain you. So support vector machine, actually the agenda behind the support vector machine, how it is. Just 1 minute. Vivek, are you there?
Let me check him. He's connecting. I don't know. Maybe something going on. It's
Okay, no issue. Yeah, let me start. I thought like he has any doubt on that. Okay. So what is here? Like let me draw it.
Hi Amit.
Yeah, hi.
Yeah, sorry, I was in a restroom.
Okay, no issue. So I was just explaining a new algorithm, support vector machine. So support vector machine, how it works. Suppose we have to classify two categories. Okay, so normally what we have seen in the linear and logistic regression, that we have one line like this, right? And we classify into two categories. Okay, suppose we have a two data points. Okay, similarly we have another data point. You can just think it like this as well, that you have to classify into two. Suppose you are passing one box to the machine, and machine has to decide whether that box is either in the diamond shape or oval shape. So how it is also a classification method, right? That you are classifying into between two categories, whether those box are in a diamond shape or whether it is a or whether it is oval shape, right? So this is like obviously we do, right? This is your maximum marginal, means this is your distance boundary, that is that classifying two categories, right? So support vector machine, what does this says? This says you that you have to try to draw a hyperplane in such a way by connecting to the end data point in such a way so that whenever any new data point will come, we're going to classify correctly on this side or this side. How it is? Suppose you see this. Okay, let me draw one more again. 1 minute. Suppose here, this is one data point which are very near. The first data point which is near to this point, and here, this one is the okay. This is near to this. Rest are, if you see here, rest are little bit faster. Okay, so with respect to this point, I will going to draw the dash line. Okay, the straight dash line I will going to draw in such a way that it should touch this line. It should touch this line or this dot point, or you can say data point, the last data point which are near. So you can see here, with respect to this data point, I have drawn this line. Okay, this line you can say it as an hyperplane. Let me draw with different color. So with respect to this line or this data point, I draw this figure or just draw this hyperplane. And with respect to here, this is the near one. So here as well, I'm drawing it. Touching to this. So this data point are called as a support vector. Okay, that is the line that you draw touching the last data point, they are actually called as a support vector. So in this support vector algorithm, support vector term comes from here, the hyperplane that connecting the last data point. Now the question is, why do we creating this? So why this algorithm work or how it works? Now it works in such a way that if suppose any data point will come, how this algorithm will going to classify that. So the inventor, they decide that if we try to maximize the distance between this distance boundary and hyperplane, then there will be more chance that your algorithm will classify any data point correctly. Okay, how it is? Suppose greater the distance here. So suppose any data point comes here. Suppose this is the data point. Okay, this is the new data point. This is the data point. You can see the shape, the attribute of this, that is the shape size, is similar to this data point, right? So it will belong to this category. Am I correct? The attribute, the shape and size belong to this one. Obviously color might be different, but the shape and size will be same to this one, so it will belong to this category. So whenever such algorithm, whenever the distance between the distance boundary and this hyperplane will be more, so obviously when you are going to do the classification, always the classification will be correct and it will going to come to this side, because the attribute of this will be similar to this. Similarly, if any new data point will come having the attribute like this, okay, they are in a different color but their shapes are same. So the number of times such data point will come will be classifying correctly, and they will come in this range only, means they will come beyond this side only. Okay, so support vector machine says that you have to draw the support vector, means you have to draw this kernel in such a way that touching the last data point, so that any new data point will come will always classify correctly. Now the question is, suppose if we do not use this line, what if we do not use this line, then it might be possible that based on the calculation distance and all, it will be belong to, it will come either on this line or it may be on the this line. Okay, so that's why what we did, that we created this additional line, so that any new data point will come, will be classified in this range only. If it come in this range, on this next side of this red line and on this green, it will be belong to this categories, or it will belong to this categories. So we try to make this support vector. Do you understand what I'm trying to say here? Do you understand the concept here?
Amit, can you explain once again? I didn't get it.
What you have not understand here?
Um, so we created the hyperplane.
Mhm.
Uh,
Okay, let me show you the first architecture, then we'll come to this.
okay.
So which is the support vector here? This one. Touching to this, we are drawing this. Okay, this two are support vector. This is your hyperplane. Okay, this is one. There are two hyperplane will be there. So you can name based on your understanding. One as a positive and another one is a negative. Anyone you can give a name. It's not like this left side will be negative or right side will be positive. It's not like, if you are giving one as a positive, then obviously the next one is a negative. Or you can give a name, hyperplane A, hyperplane B, as they have just used the naming convention here. Now here what this says, let me give you an example here. Okay, so how this work, just read this, just read this example once, then I will going to explain you. First read this example. Have you read this? Have you read this?
Yes.
Okay, so what this says, let me now explain you. So suppose this side is your cat. Okay, suppose this is your cat and this side is your dog. Okay, you are making a classification. So what does it actually, this support vector means? Support vector means it's an extreme case. Okay, it's an extreme case whose features is similar to both, right? For example, dog and cat having similar feature. What are the similar feature they have?
4 legs,
Yes, correct. Four leg.
2 eyes,
Yes.
4.
They also omnivorous, right?
They both
Means
have 4.
tail.
Mhm.
And what else you said?
The 4 hair.
Yeah, that everyone they have. Yeah, okay. Here that is, but every animal they have, so that is we cannot take it. But these are the main things: two eyes, four leg, one nose.
Mammal.
Yeah, good. They are classified as a mammal as well. And so, sorry, date, not date, cat and dog. Yeah, so here they have four leg, two eyes. They both eat flesh and vegetarian as well. Tail they have, nose they have. And they are also mammal, right? So this support vector actually means these are the extreme point which are having a feature similar to, which are contiguous, means ambiguous. So that's why they are coming at the very end of this hyperplane. Okay, so with this, by taking into consideration this one, whenever any new data point will come, we're going to classify. But extreme case means suppose you have a suppose your data point comes which are having these all properties. Now if I say you whether it is cat and dog, how you're going to decide? Both are they having same feature, right? Usually we can decide it either by sound, dog bark and cat meow, right?
Good
So
sense of smelling.
yeah, that also you can say it. And both are pet animal as well. So but cat can be used as a like in a house, but dog are like for security and all that also you can say it. So if these are the two features, if we use this one, you can easily classify whether it is dog and cat. But if I consider this one for like two, I will you able to classify? No, right? Because both of them have been same. So here suppose that any data point which are very extreme means uh, at the we classify them like at the very end, that this is classified to the dog categories by making some features. So extreme data points are those are having features similar to both categories. So taking into consideration that one, whenever any new data point will come, we're going to classify. That's why taking into consideration this support vector, we draw this hyperplane, and always whenever any new data point will come, we're going to consider this data point and we're going to classify into categories. Now suppose if any data point will come, whether it is cat and dog, whatever it is, you're going to match the feature of this data point with this one, and based on that it will going to classify. If it come inside this, then obviously it is dog. If it come on this line or in this portion, then it will be cat. So like this support vector works. Do you understand this? This support vector to whom we call the last data point, which is the extreme data point whose feature is ambiguous and similar to both cat and dog. So by taking into consideration that data point, we're going to further do the prediction and classification. Do you understand now?
So Amit, if the data point is like both attribute dogs and cats, so how we figure out it's dogs or cat? It has a both attribute, right?
So it will going to be called as an outlier, means they will mismatch, they will misclassification in that case. If you don't have any feature that can uniquely identify dog and cat, then that data point will be either called as an outlier, which is do not have a unique categories, unique attribute, or even
Okay.
or sometimes they can be misclassified. Either they will come to this one or they will come to this area.
Okay.
So always it
So,
will be misclassified.
so the extreme database will have uh, the extra features like whether it's going to be meow or it's going to be bark, right? So that we
Mm,
can
yes.
categorize them. Okay.
Yeah.
So the other rest of the database will only have the common features.
Yes.
Okay.
Means this particular data point will be helpful in making a decision. So this data
Okay.
point is accurately classified. So this means that you are going to take this to make further decision that any upcoming data point will belong to this dog categories or cat categories.
It's like a
Oh,
base
Yeah,
because
best. Yeah, you can take optimize or best data point. That will be helpful.
okay, Amit.
So this is called as a support vector. In this way it works. Can you see my screen?
Uh-huh.
Yeah. So
Yes.
here, this is the example that you will have a data of attribute dog and cat. You are going to train the model, and whenever new data will come, you are going to classify.
It's a little bit similar like a KNN
No,
algorithm.
no. Similar means in KNN you are finding, you are taking considering the K value. Are you considering K value here?
Oh, okay.
You are not considering K value. You are considering support vector. You are
Okay. And
considering only that one
yeah,
extreme data point, and
and
you
we
are
take
yes,
distance in a
yeah,
KNN, right? Yeah.
yes.
Okay. Okay.
So those are the data points. So the reason is we always try to make the distance between the this hyperplane and this optimal hyperplane maximum. This distance maximize so that whenever any new data point will come, they will either come on this line or they will come to these categories. They will not come on this category. The reason is, if you keep this distance very small, then in the future it might be possible that they can be overlap or they can be misclassified. So we always try to we try to make the distance between this hyperplane and this optimal hyperplane, that is called decision boundary, maximum. You can see maximize margin, so that whenever new data point will come, they will be either on this line or in this portion, not overlap on this two or misclassify. So we always try to make the distance as maximum as possible. This is the most asking interview question. Why do we make the distance between optimal margin and support vector maximum? So that they should be not misclassified. So what you're going to say the answer, that we should make a distance as maximum so that they should not be misclassified. Do you understand?
Yes, sir.
Yes, sir.
And the example, the coding will remain same. The coding, you can see it here. What I explained you last time will remain same only. What will going to change it here? The same as we said, whether the person will going to purchase or not, you have to change it here from sklearn.svm import svc.
Just
Last time,
algorithm, right?
yeah. So svm is the name of algorithm. Just like we were using knn, import logistic regression, import linear regression, import decision tree, import random forest, import neural network. So here also you have to do it. Then in support vector classifier, you have to just pass one parameter, that kernel means type of svm you want is linear. Linear means linear classification. Means linear classification means what? That can be separated into two category exactly. It's not like that. Is this is called, when you're going to do classification like this, circular multiple classification, that is called 3D space. But in 2D space, you are going to make linear classification. How you're going to make linear classification? Like this. Two categories. You are going to make into two categories. This portion, this portion. In 2D space. Like here, you're going to draw the line and then you're going to draw maximum margin. That is called linear. So you just have to pass that I want to consider SVC as a linear, and then just run it and then just call this classifier.predict on the test data. So it will going to give you the value for the purchase column, what will be the output. Then you can match it with the actual data in the data set and the output that you are getting. Y prediction is your output that you have received or that you obtain now after running the algorithm. So you can match it with this data set value, this one, to check whether the value is matching or not. Wherever the value is not matching, it means that particular data point is mismatch. Okay, obviously 100% accuracy you won't get. You will get accuracy like 98%, 95, 98, but you won't get 100% accuracy, right? So this is what about support vector algorithm, support vector machine. Anything that is you want to ask, anything that is not clear here? You can see here as well, we are classifying into two categories, but still some of the green data points are coming into this side and some of the red data point are coming to this side. Why? Because there are some data point whose features are similar to the green one. There's some data point of a red similar to the green one. So we're going to classify those. So these are called misclassification data point. Out of 100, there might be 10 data point that can be misclassified. Okay. So this is about support vector machine. So we are done with this support vector. We have already completed algorithm part, and so one more algorithm is there, that is a association mining rule, but that is completely mathematics. So I won't suggest you to focus right now because you will get confused there. So everyone, are you confident enough of, if I ask you about the algorithm, will you able to explain me any algorithm, or you want time to go through it?
I don't know. I didn't get chance yet because last week was my final week. So maybe I'm gonna go from today. I have time. So
Okay,
yeah.
what Urmila, Vivek?
Yes, I'm working on it, but not completely.
Okay, so you go through this today. I can do one thing. I'm okay. You go through this algorithm because tomorrow I will going to start a visualization, and on this Saturday we're going to do some lab on this. Lab means I have not shown you running program, right? So I will going to show you the running program, and we're going to
Mhm.
install a Jupyter Anaconda as well. This program will going to run it and see on the Saturday. But tomorrow one algorithm I will going to show you naive bias, and we're going to uh, start tomorrow that your data visualization.
So
Google data.
tomorrow we have
Yeah.
one more algorithm.
Yeah, one more
With
algorithm. This not usually asked, but naive bias I will going to explain you so that you should be
what
aware
is it?
about NLP also.
Oh,
NLP is a natural language processing that usually used for searching the language, like Alexa, Google Siri, Google Voice Search, Amazon Alexa. They work on this naive bias, and they work on deep learning algorithms. So this I will going to explain you tomorrow. Naive Bayes algorithm.
okay. I mean,
So tomorrow I'm going to cover this, and so I will suggest you go through this all algorithm today, and then
okay,
on Wednesday onward we're going to start data visualization in the Power BI tool and Google Data Studio. So by this week I will cover data visualization. Then from next week, 1st of December onward, database will I will going to start.
okay.